Okay, next part, piston crankshaft. So if you look here, we have got 1, 2, 3, 4. There's only 4 components, but you have to make it a lot. You have to do something called subassembly. So if you look at these pistons, they are, if you assemble it properly, it should be aligned. So you've got 4 pistons. So this is inline pistons. This is the crankshafts. Okay, so let's start. Go to SolidWorks, File, New. It is an assembly. Let's assemble this thing. Create a layout. Okay, never mind. Browse. Let's choose your piston. So I want to start with the sub-assembly first. Why? Because you've got a few repeating parts. This piston with the crank, with the connecting rod, this connecting rod with the piston, right? You can create this under one sub-assembly, and then you can just recall the thing. So you don't have to do multiple mating features that is very repeatable. So I'm going to call, let's make this one upper large. This one upper connecting rod. Insert more components, browse. These two things. This one and this piston. Obviously, this is the first part, right? So the first part is kind of fixed. Never mind. This thing is here. So you know what to do already. Click on Mate, concentric, this circle to this circle, and then you don't need to escape the feature. Concentric again, this circle to, oh no, I need to accept first. Click this circle to this circle. It will align it together, and then click this surface and this surface. It will coincident for you guys. It's kind of intelligent. Next will be this thing. This thing needs to go inside here. However, they need to be in the middle, right? So this has to be in the middle, right? So you know what to do. Number 1, obviously, concentric. This circle to this circle. So now it is along that particular axis. Next thing, you need to do something called advanced mates and then choose width. The width is between this surface to this surface towards this surface to this surface, and then click on accept. So now you have something like this So this is something called piston sub-assembly. Accept. Everything is done. Should I make this fixed or float? Doesn't matter. Later on you will learn. I'm going to show you. So file, save as, rebuild and save the document. Don't show again. I'm going to call this one sub RC. Sub RC stands for sub-assembly So sub-assembly. Save as. Okay, click on save. So this is a sub-assembly. Make sure you remember where you put this one So next will be file, new. Assembly. Click on OK. We are going to insert component, browse, crankshaft. So crankshaft is here. So once you have your crankshaft, this crankshaft is actually fixed, right? You cannot move this crankshaft anywhere. Make sure you turn this one to float. So this thing is floating. However, there's a problem. This crankshaft cannot be rotated. You can pan this, you can move this crankshaft. However, you cannot rotate this crankshaft. In order to rotate this crankshaft, you need to create something called axis. In order to create this axis, you can choose insert assembly feature, no, reference, yeah, reference geometry, axis. So you need to put an axis lah, then you can concentrate this part to that particular axis, then it will be able to rotate. So click on insert, reference geometry, choose axis. Axis will be on one of the easiest one is two planes lah, two planes. Which plane? Top plane and no, not right plane, front plane. If you choose front plane and then okay, choose accept. So this axis will be there. So now it's gone. If it's gone, you need to turn it on. How do you turn it on? Choose this one. Click on your eye. These eyes, we turn on axis, view axis. So you've got axis 1. Axis 1 is here. So now what we should do is, we should make concentric, this one, to this axis. So now we can rotate this axis. We can rotate. Just now we cannot rotate this crankshaft. But now we can rotate already lah. But the problem is it's moving like that. So if it's moving like that, that's fine. We need to turn on certain things lah. Maybe right plane. Right plane is there, we can turn it on. Click on show. So dia gerak-gerak macam tu kan. It's hidden, right? You have to turn on here. Turn on this one, planes. Now you can see certain planes. So now you want to make it flat like that. So what do you do? Make coincident lah, this surface to this plane. And then accept. So now it rotates. Yeah, now it rotates. So now you've got a crankshaft that rotates properly. So if you feel that all this plane and axis is disturbing your view, you can turn it off again. Click here, turn off planes, turn off axis. So it's gone. But then you still have your shaft lah. Your shaft is still rotating. What next? Yeah. Insert component. You should browse to your subassemblies, or it's here, subassembly. So you've got this subassembly. What are my options? Thumbnail. Okay. Graphics preview. So click on like that. So you've got one subassembly. How do you duplicate this subassembly? Click this thing. Click control. Drag it. Oh, cannot lah. Only piston is being duplicated. But the whole subassembly is not being duplicated. So call again lah, insert more components. Subassembly. Another one. Insert more components. Subassembly. Another one. And then final one, subassembly. Another one. So we've got 4 subassemblies here. You are going to be assembling this to all the crankshaft locations. look at your PowerPoint. If you are confused, where is it supposed to be located? Look at your PowerPoint. It is supposed to be at between these shoulders, between these tabs, in the middle of the thing. What next? Yeah, mate, and then choose concentric. Choose this circle and then this surface, and then accept. What next? Advanced mate, choose width between the surface and the surface, and this surface and this surface. There you go. Yeah, done. Click on accept. Next, make so before we move on, there is a very simple feature which is something called Midcopy. If you have repeating objects, an object that is that needs to be assembled with repeating steps, you can use something called Midcopy. How do you search for this feature? Maybe we can go to Google. Midcopy SolidWorks. Midcopy, copy with mates. Yeah, this is the one we are talking about. Copy with mates. Let's look at this example.
Welcome to the Nova System snippet video. Mates which are applied in the correct. Simply write the component throughout the assembly. The component going to copy with mates. The rest of the assembly. Simply right clicking on the component. I'm going to copy with mates.
Copy with mates. Okay, so click on the component. Copy with mates. I think cannot do that. This one. Right click. Copy with mates. Select components to copy with mates. This component. Which component? This one. Oh, you have to choose here. Choose this one. Okay. And then next. Concentric. This is concentric, right? So concentric, this one. Width. This one. This one. That's it. Is that it? Accept. Is that it? Oh, it's done. Yeah, this is so easy, right? So you don't need so many parts like this. So this one, Subassembly 4. Let's check out our model 3. Subassembly 5 is here. This one no need. This 3, delete. Yes to all. You don't need to do that. You just have to select this one. Copy with mate. Where did I go? This one. Copy with mate. Oh, okay. It has to be under mate code. No, it's not. There you go. Copy with mates. Copy with mates. Select which component. This one. First one. Okay. Click on next. Concentric to here. and then width here to here. Done. And then dia suruh tanya lagi concentric kat mana lagi I think this command is not yet finished maybe I can choose another one. There you go. Then this one and this one. There you go. You don't even need to get out of the command. Mates to be copied with selected feature are underdefined. I haven't choose width this one and this one. Okay. Extra. So what do we do now? Can we rotate this crankshaft? Yes, this crankshaft can be rotated. However, we have a problem. What problem? Control 8. So if you want to look at certain view, for example, you want to look at the top, click this view and then click Control, press 8. It will change to normal to the view. If you want to look from this view, click here and then Control 8. It will look at normal to the view. So I want to look at here. This line, Control 8. Of course, if you want to change view, you can click arrow on your keyboard. Click arrow. Arrow on your keyboard. It will rotate your view by, I don't know, 15 degrees each. So it is like that. So let's say if my crank were to rotate, it will be, this is not correct it will be clashing with what it will be clashing with the surface of the engine. It's going to clash. So this is not what it is supposed to be. How it is supposed to be? Look at your practical. It is supposed to be rotating, but inline with the surface of the engine wall. Currently, it's not inline anymore. So what we should do is we should change a few things. Number one, I've got subassembly here. Subassembly 1, 5, 7, 9. Can I rename this one? Rename. Boleh ke rename? Double click. Definitely can rename lah. Maybe you're gonna look here. Edit mates. No, rename. If you want to rename, you have to rename the part. Subassembly 1. So under the subassembly, one thing you should do is you should go to this one. Make subassembly flexible. This one is important. Our current subassembly is fixed like that. You cannot rotate. Click on subassembly 1, make subassembly flexible. So now, can you see the icon change here? Subassembly is now, I can do that. I can wiggle. This thing can rotate like that. The rest, no, it's fixed. So if the subassembly is flexible, it is like that. Sure. So repeat the same thing. This icon, right click, change to flexible. Icon is change to flexible. That's this bincang. Okay, the last one only. This one also can move. This piston can move. This one cannot. Fixed, rigid. So the last subassembly 9, make it flexible. So everything is now flexible. So the thing is, I want to make it like that. I guess what I think one of the easiest way now I should do is I should turn on planes. Not the right plane. Right plane I think I can hide. I think I should turn on top plane. So whenever this thing is okay, top plane. Yeah, I can move this one. Whenever this thing is rotating, I want all the top of my piston surface is parallel. It should be parallel to this rotating. So this is my reference lah. My top plane is my reference. Everything can move and change direction. However, my top plane is remain fixed. So I need to do a mate. Mate. Keep it parallel. What do I choose to be parallel? This one to top plane. Boleh lah. Is that a good idea? Can lah, trial and error. There's no other way to learn. I'm making this parallel. This surface to this parallel. Okay, never mind. Let's try again. Mate. Why is this thing turned on? Parallel. No more insert component. Mate. This surface to this top plane. Is that a good idea? What's happened now? Or did I choose coincident that one? Patutlah. It's not coincident, right? Parallel. Kalau parallel dia gerak lagi. Coincident tak boleh buat apa lah. Macam ni kan, I can rotate this one. Let's see, I want to rotate this one. Oops, like that. Let's make this parallel. Mate. Parallel this surface to this surface. And then click OK. And then parallel this surface to parallel top plane. Accept. Okay, see what happens. It's like that. You can rotate however you want. Okay, let's view this. Click a surface, control it. Now let's rotate our crankshaft. My crankshaft is behaving very badly. No engine is working like this. Can my engine is working and rotating. Maybe got also non-inline engines. We are talking about inlines. Let's Google inline 4-cylinder engine. What is it? Inline 4-cylinder engine. Inline 4-cylinder engine images. This is what we are talking about. It has to be inline, which is one line. Ada ke engine yang macam star ataupun V? Oh, V ada kan? Inline. No, V. Can we change to V? V. V also got. Got kah? This This is V lah. It's like a curve like that. But we're not doing that. We are doing this one lah. Inline. So look at our design. Look at our... This is not inline at all. So what do we do now? How do you make it inline? In order to make this inline, there's a few tricks to it. One way is to find something which is common to all of them. For example, let's look at our subassembly. In our subassembly, there is something called a piston head. Right, this is a piston head. Under the subassembly, the first subassembly, where am I looking at? Let me repeat again. I've got subassembly 1, subassembly 5, subassembly 7, subassembly 9. Yours will be different lah. 1, 2, 3, 4 lah probably. Subassembly 1. Under subassembly 1, there will be piston head. This is the piston head lah, the blue color. Under this piston head, there is something called front plane, top plane, and also right plane. What I want to do is I want to turn on right plane. See? If I turn on the right plane, the whole right planes can be seen. Now, let's take a look again at that perspective. I want all these right planes to be in line with each other. How do I do that? Coincident lah kan? Really ah? I think so. Coincident. Kalau parallel dah parallel lah. It is already parallel. Oh, I think this mate we don't need to do this parallel. If it's inline together, everything is good already. I think this fourth thing is no need to do. If you want to delete but you're not sure, you don't have to delete. You just have to suppress. Suppress will remove the command, will remove the feature, but then will not delete. It is still there, but not activated. So you can use suppress. Once you are confident that this command is not required, you can later on delete. Suppress is something that you can activate back if you feel that that feature is required lah. But at this time, I think it's a good idea to save. Save as practical 1 actually. Practical 1 C lah. 1 C lah. Boleh lah. Okay lah, 1C. Or practical 3. Depends on you lah. So, I think this is the last thing that we need to do. Make coincident. This one to this one to this one to this one. That's not good. I think I need to turn on one more plane code. Let's try again. It's gotta be. Look at this crankshaft. Crankshaft car. Oh, look at this. This front plane. Turn it on. This top plane I can remove, I think. This top plane I can remove. Hide. Okay. Let's look again from this angle. Control 8. I've got a front plane. This front plane, when the crankshaft is rotating, I want to make it inline. So what I do now is I'm going to align them together. So mate coincident. This front plane with this guy, with this guy. Oh, I should do it multiple times. In this guy, in this guy. No, this is wrong. Escape. If you are doing a mistake, you can escape. I think this command has to do it multiple times, 4 times. Mate coincident. Front plane with right plane. So click on accept. So let's see, Control 8 rotate. See, I've got one piston in the correct position. I'm gonna choose the next piston. Coincident this right plane to this front plane. Accept. Let's check it. Rotate. So I've got two piston in the right position. Coincident right plane with front plane. Accept. Let's do it for the rest. Coincident this right plane with this front plane. Accept. Now let's take a look at our engine assembly. There you go, perfect. This is for inline engine, 4-cylinder, like what you see in a internal combustion engine. So this is what we want. All 4 pistons must be aligned. I guess for this week, yeah, that's it lah. For this week, Monday class, we're going to be doing this only. However, make sure you save all your work. We are going to continue on with this one later on with motion analysis. So make sure you can control it and you can rotate. Everything is inline. So once you've done this, you can click on the eye and then turn off the planes lah. Make sure you file save. File save. Save your files, okay? Because next part is motion analysis. Do this one first. Later on, do the motion analysis, okay? Alright, see you on... when is our next class? I'm gonna see you there. Thursday, I think.